Now next question is limit x tends to 0, 1 by x minus 1 by e raised to x minus 1, that is infinity minus infinity form. So you will get it as e raised to x minus 1 minus x by x into e raised to x minus 1. So now this is in 0 by 0 form. So that will be equal to limit x tends to 0, e raised to x minus 1 by e raised to x minus 1 plus x e raised to x. So again that is in 0 by 0 form. So applying the L'Hospital rule again. So you will get limit x tends to 0, numerator you will get e raised to x, and in denominator you will get e raised to x plus x e raised to x plus e raised to x. Okay, so you have e raised to x, the derivative of x e raised to x is x plus 1 into e raised to x. So that will be limit x tends to 0. So e raised to x will cancel off. So you will get 1 by x plus 2. So the value of limit will be 1 by 2. And now let us look at different problem. So limit x tends to plus infinity ln of x minus ln of 1 plus x. So here you have an infinity minus infinity form. Now this is not in the form of a ratio. Denominator എടുക്കാനൊന്നുമില്ല. So here what we do is, so you can write it as ln of x by 1 plus x. Now as x approaches to infinity, limit of x by 1 plus x goes to 1. So when you take the limit of this term, x by 1 plus x, that will be equal to 1. So therefore this will be equal to ln of 1. So that will be equal to 0. So here we need not apply the L'Hospital rule. അല്ലാതെയാണ് നമ്മൾ simplify ചെയ്യുക. Okay. So this is an example where you need to do other adjustments to find the limit. And next one more problem. So limit x tends to infinity x minus ln of x square plus 1. So here also it is an infinity minus infinity form. So here what we do is, again here there are no ratios. So I can write it as ln of e raised to x. X in a log exponential function, they are inverse functions. So I can write it as ln of e raised to x minus ln of x square plus 1. So that is limit x tends to infinity. I can write it as ln of e raised to x by x square plus 1. Now when you take limit x tends to infinity, e raised to x by x square plus 1, that will be equal to limit x tends to infinity. നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ കണ്ടാണ് e raised to x by x raised to n ഫോമിൽ വരുവാണെങ്കിൽ നമ്മുടെ ഡിനോമിനേറ്റർ ലാസ്റ്റ് നമ്മൾ ഡിഫറൻഷിയേറ്റ് ചെയ്ത് ഫൈനൈറ്റ് ആവും. ന്യൂമറേറ്റർ will again remain e raised to x. So this limit is going to be infinity. So when you take the limit, this term goes to infinity. So that is ln of infinity. So which will be equal to infinity. So the limit is infinite in this case. So these are a few examples of infinity minus infinity form. And നമുക്ക് മെയിൻ ആയിട്ട് ഉള്ളത് 7 ഇൻഡിറ്റർമിനേറ്റ് ഫോംസ് ആണ്. യൂഷ്വലി നമ്മൾ ഇൻഡിറ്റർമിനേറ്റ് ഫോംസ് ക്ലാസിഫൈ ചെയ്യുമ്പോൾ 7 ഇൻഡിറ്റർമിനേറ്റ് ഫോംസ് ആണ്. നമ്മൾ 4 കണ്ടു കഴിഞ്ഞു. 0 by 0, infinity by infinity, then 0 into infinity, infinity minus infinity. The next set of indeterminate forms are, so the The last type of indeterminate forms are, so they are of type, so we have 0 raised to 0, then infinity raised to 0, and 1 raised to infinity. So these are the last type of problems. Okay. Now, ഈ ലിമിറ്റ്സ് എല്ലാം നമ്മളൊരു കോമൺ വേയിലാണ് നമ്മൾ evaluate ചെയ്യുക. So here your expressions will be of the form. അപ്പോൾ നമ്മൾ ചെയ്യുന്ന പ്രോബ്ലത്തിൽ നമ്മുടെ ലിമിറ്റിന്റെ എക്സ്പ്രഷൻ എന്ന് പറയുന്നത് that will be of the form f of x raised to the power g of x. So it can be either in 0 raised to 0 type, infinity raised to 0, or 1 raised to infinity type. So ini namukku, if you have a function of the form y equal to f of x raised to the power g of x, then when you take logarithm on both sides, so that gives log y will be equal to g of x into ln of f of x. So what we do here is, അപ്പോൾ നമുക്ക് ഈ ലിമിറ്റ് എടുക്കുമ്പോൾ നമ്മൾ നേരത്തെ കണ്ട ഫോംസിൽ ഏതെങ്കിലേക്കും നമുക്ക് കൊണ്ടുവരാൻ പറ്റും. അല്ലെങ്കിൽ 0 into infinity ടൈപ്പ് ആയിരിക്കും, അല്ലെങ്കിൽ 0/0, അല്ലെങ്കിൽ infinity ടൈപ്പിലേക്ക് നമുക്ക് കൊണ്ടുവരാൻ പറ്റും. സോ ദെൻ ലിമിറ്റ്സ് എടുക്കുക, രണ്ട് സൈഡിലും ലിമിറ്റ്സ് കണ്ടുപിടിക്കുക. സോ ടേക്ക് ലിമിറ്റ് ഓൺ both sides. So find out the value of this limit. Say this is L. So therefore limit of y will be equal to e raised to L. So taking exponential on both sides, so we will get the final value of the limit. So that is how L'Hospital rule is applied when you have these forms: 0 raised to 0, infinity raised to 0, or 1 raised to infinity. So let us quickly do an example. So find limit x tends to 0, 1 plus sin x whole power 1 by x. So this is in 1 raised to infinity form. So this is an indeterminate form. So now you have y equal to 1 plus sin x whole power 1 by x. So take ln y will be 1 by x ln of 1 plus sin x. So now take limit x tends to 0, ln y, that will be equal to limit x tends to 0, ln of 1 plus sin x by x. So you can see that when x is 0, this is in 0/0 form. So applying the L'Hospital rule, that will be 1 by 1 plus sin x into cos x by 1. So taking the limit, you will get cos 0 is 1. So 1 by 1 plus 0. So value of limit is 1. So that is the limit of log y. So limit x tends to 0, ln y will be equal to 1. So that implies limit. So taking exponential on both sides. So limit x tends to 0, y will be e raised to 1. So therefore limit x tends to 0, 1 plus sin x whole power 1 by x will be equal to e. That is the required limit. So let us see one more example. Find limit x tends to 0 plus e raised to 2x minus 1 whole power x. So this is in e raised to 0 is 1. So 0, 1 minus 1, 0 varum. It is in 0 raised to 0 form. So take y equal to e raised to 2x minus 1 whole power x. So ln y will be x into ln of e raised to 2x minus 1. So take limit x tends to 0, ln y, that will be limit x tends to 0, x ln of e raised to 2x minus 1. So this is in 0 into infinity form. So that will be limit x tends to 0 plus sign. So limit x tends to 0 plus. So I can write it as ln of e raised to 2x minus 1 by x. So upon so now this is in infinity by infinity form. So taking limit x tends to 0 plus. So you will get 1 by e raised to 2x minus 1 into 2 e raised to 2x by minus 1 by x square. So that is limit x tends to 0 plus minus 2 x square e raised to 2x by e raised to 2x minus 1 varum. Once again take the derivative. So it is again in 0 by 0 form. ഒന്നും കൂടി differentiate ചെയ്യുക. So that will be limit x tends to 0 plus. So you have minus 2x e raised to 2x plus x square into 2 e raised to 2x. ഇനി നമുക്ക് ഡിനോമിനേറ്ററിൽ 2 e raised to 2x varum. So e raised to 2x will cancel off. So that is limit x tends to 0 plus minus 2 into 2x plus 2x square by 2. E raised to 2x cancel out. So upon taking the limit, you will get 0. So therefore limit x tends to 0, ln y equal to 0. So therefore limit x tends to 0, y will be e raised to 0, which is equal to 1. So therefore limit x tends to 0, e raised to 2x minus 1 whole power x will be equal to 1. So that is the required limit. Let us look at one more problem, that is limit x tends to infinity 1 minus 3 by x power x. So this is in 1 power infinity form. So take y equal to 1 minus 3 by x whole power x. So therefore ln y will be x into log 1 minus 3 by x. So take limit x tends to infinity log y. So that will be limit x tends to infinity. So we have log 1 minus 3 by x. Ini x ന് പകരം എനിക്ക് 1 by x എന്ന് എഴുതാം. So now this is in 0 by 0 form. So applying the L'Hospital rule, so that is limit x tends to infinity 1 by 1 minus 3 by x. So by chain rule 1 by 1 minus 3 by x into 3 by x square varum, then minus 1 by x square. So 1 by x square will cancel off. You will get limit x tends to infinity minus 3 by 1 minus 3 by x. So therefore the limit value will be minus 3. So that is the limit of log y. So taking exponential. So limit x tends to infinity ln y is equal to minus 3. So therefore limit x tends to infinity y will be equal to e raised to minus 3. So therefore the required limit 1 minus 3 by x whole power x will be equal to e raised to minus 3. So that is the required limit.